I'm not sure if I'm supposed to be here as a customer or as a partner, but NVIDIA is, of course, both a large customer of DDNs as well as a partner. I think it's not surprising that the room is full here, because anyone today that has a user group or presentation and is talking about AI, the rooms tend to be full. And I know a lot of you, most of you, started your careers or maybe a strong history in high-performance computing. But when you go to something that's only entitled high-performance computing, often the room is not that full. And of course, it's not because high-performance computing isn't important. In fact, AI has become one of the most demanding and largest workloads for high-performance computing. And I think because of that, it's why we have such a good partnership with DDN is because it turns out you cannot really build state-of-the-art high-performance computing systems for scientific computing or AI by just building a GPU, a CPU, a network chip, a QLC chip. You wouldn't go to DDN to buy a QLC flash chip. You go to DDN to buy a storage solution. But with your AI system, with that HPC system, the storage system is inherently a key part of the supercomputer, of the AI supercomputer. And that's really how at NVIDIA, while many of us had worked with DDN in the past, we started working with them really as a customer, long before we started working with them as a partner. 2015, we started the design of our first supercomputer that we used in-house internally, deployed on the top 500 list in 2016. And in fact, when we were designing it, Jensen Huang, our CEO, he asked me, he said, well, how big a supercomputer should we build for NVIDIA? We're around a conference room table, and our CFO then woke up, sort of gave me a dirty look. Don't say too big, that's my money you're spending. And I said, well, Jensen, how big of one do you want to build? And he goes, well, what's the benchmark for AI supercomputers? This was 2015. And of course, there were no benchmarks for AI. But Jensen was smart. We had sold a few top 500 systems. So he says, what's that benchmark you're always telling me about, the top 500? Let's build a system for the top 500. And I said, okay, well, where do you want to be on the top 500 list? I can build you any size system. And he said, well, we want to build a system not to get on the top 500 list. That obviously isn't the goal. We want to build a system to attract AI researchers and developers to NVIDIA. And so being 490 on the top 500 list isn't too impressive, but we don't need to be top 5. He goes, what about top 50? So I said, okay, and we delivered, I think, was a number 31 system initially. Our last supercomputer on the top 500 list was number 5, and the one we're building now, I think by the time it's done later this year, I don't think anyone's going to care where it is on the top 500. It's almost irrelevant, but it will be number 1, we expect, in AI performance. But what else is important, of course, as you're building up that performance? You heard it right at the start from DDN, power, right? Every data center is out of power, right? The only way the data centers often can add compute for new scientific computing, for new AI computing, is to reclaim power. You can't turn off the heaters in the winter or the air conditioning in the surrounding buildings. The only way to reclaim power is to take workloads that are not accelerated and accelerate them, thus saving power. And of course, one of those new workloads that I expect will drive a lot of DDN storage is quantum computing. Right? NVIDIA, of course, is not today working on a quantum computing chip, but of course if you want to win a Nobel Prize in quantum computing, you need to probably develop an algorithm with 1,000 qubits. And of course, you can't do that with a 50-qubit system. The only way you can do state-of-the-art research in quantum computing today is with simulation. So again, it turns out that the same exact requirements for high-performance computing needed for AI, needed for traditional simulation, are also needed to simulate quantum circuits. A few announcements that we'll talk about. Speaking of power savings, NVIDIA's been working on our own CPU that we call Grace for a number of years. It's finally now in production. We'll be announcing in the next week or so the ship dates for it and the pricing for our developer kit. Computex is next week. I'd encourage you, if you had, I think that if you can go buy a couple of the developer kits and hold on to them, that they'll be very, very valuable. People will bid up the pricing of it. But we're going to come out with a very low-cost developer kit to get the Grace CPU out into the market. 2 versions of it, one a CPU super chip and one a CPU and a GPU working together. In both cases, these won't be replacements for our current x86-based systems. The de facto standard for AI for compute has become our HGX platform. 2 x86 CPUs, 8 NVIDIA GPUs. That's standard for training large language models, training ChatGPT, doing other deep neural network types of training. Will continue, we believe, to be very, very popular. But there's other workloads that we believe we can optimize around. Workloads that are very memory bandwidth intensive, being able to connect the GPU with the chip-to-chip NVLink to the CPU and the CPU memory. One of the big power savings, besides the ARM architecture, comes from the CPU memory. About 70% more power efficient at the server level because you don't have all of the DDR memory to drive. So again, a lot of interesting news. And of course, we'll be building our own supercomputers that you'll see, as well as ones that have already been announced here in Europe and around the world. Very interestingly, we did announce today a new supercomputer with the University of Bristol. This is not a GPU system. This is a CPU system. You probably never thought that you would see a big 55,000 ARM core system announced. You'd never see NVIDIA talking about a 55,000 CPU core system. But here you go. This is one of our first CPU-only supercomputers that we're announcing. Here's some of the other ones around the world that we've announced. Again, from the US to the Middle East to here in Europe. NVIDIA Quantum, again, is saying, well, if quantum simulation is a solution and you're not making a chip, then what are you doing? Just selling GPUs to them? We're not. We're developing a whole software development kit and series of software to help you develop quantum simulations on top of the GPU platform, doing a number of different functions. So in light of that, we're very happy to announce today one of our joint labs with Jülich around quantum computing. I know some of you say, oh, I thought Jülich was working on another big system. So this is not a system announcement. This is a joint lab to work on quantum computing. So we're very excited about working with Jülich and Partech in this lab. Rolls-Royce. We announced today that with Rolls-Royce, we've simulated the world's largest circuit, quantum circuit, for computational fluid dynamics. So again, more information in our press releases around that. And here's one around AI. And so this one, you say, well, ServiceNow, don't they do like your Windows help desk? Why are you making an announcement at an HPC conference? This actually wasn't an announcement at the conference. We announced this last week. ServiceNow had their big user group. ServiceNow has over 10,000 customers, some of them very big customers. Nvidia uses ServiceNow, but in every industry. And think about it. The help desk for Nvidia, we probably ask different questions than the help desk for Carrefour stores or the help desk for BMW, right? And so today, ServiceNow, they have their help desk people. Sure, they all know Windows at some level, but then they're specialized by industry or elsewhere. And think about it. ServiceNow there's some open source data sets that cover call center logs, but they're open source, right? They're pulled from the internet or the like. ServiceNow has every chat, every phone call they've ever had with their 10,000 customers stored. It's not available to ChatGPT because it's not on the internet. So they're going to train large language models like ChatGPT for their customers. Ideally, they would like to train a separate model for every customer. Maybe in the start, they'll train one IT model. They'll let DDN, I don't know who DDN uses for their help desk, but DDN, Intel, and Nvidia might all get the same model. And then they'll specialize the model. Intel's one will give a slightly different answer than Nvidia's or DDN's. So we're very excited about this. Here's just a very early example. We trained a model on ticket summarization. Right? You've all seen examples. You can go to ChatGPT and say, summarize here's some text, summarize this text. And so we trained that. We trained a model for that. And with this is a research and development. It's not rolled out. It's not in the ServiceNow platform yet. But they estimated that just with this one model, they can save 7 or 8 minutes per help desk call. That's pretty valuable if you think about how many help desk agents they have and what is 7 or 8 minutes per call. So back to why DDN. Why have we worked with DDN? And I think this chart is the one that summarizes it the best. You can start small and scale linear. So I said earlier, since 2015, we've been designing our own supercomputers. We have tens of thousands of GPUs owned by NVIDIA or in the cloud rented by NVIDIA that we run internally for our own software development. About 4 years ago, when we were expanding our system, it of course ran on InfiniBand. We hadn't acquired Mellanox yet, and we wanted to expand it. So we had to add a new InfiniBand switch as we added nodes. And of course, the MLPerf, by now 4 years ago, there was a standard for AI benchmarking, and the new MLPerf deadline was coming up. And so our AI team said, well, look, if we're going to stay number one, we need to double the number of nodes. And it has to be done by 2 weeks before so we can run the benchmark. My team came in and said, well, when we installed that system, there's all the cables in the ceiling. We never planned to take it apart and expand it. We can't undo all those cables in 2 weeks and get them reinstalled. We're going to have to cut them. It was about $1 million worth of cables. And so I didn't even ask. I knew if I asked my CFO, I would get not an answer that I wanted. And so I wanted to let Jensen claim ignorance. So we went ahead, cut the cables. We got $1 million worth of new cables, installed the new switch, one MLPerf again. And then when I went and told Jensen, he said, look, I'm not upset, Mark, that you spent $1 million. I would have been upset if the team had not won MLPerf. He goes, but our customers may get upset if we cut up $1 million worth of cables when we want to expand the system. Can you design the supercomputer in a more modular way? So that was when we were in the DGX2 V100 architecture. And so when we premiered the A100 architecture several years ago in the DGX A100, we had a new, we took a page book again from supercomputing. Design your system using scalable units. that you can then add different sizes. And so at the time, our DGX SuperPod was 20 DGX systems. DDN was the first and for a long time only storage partner that was qualified as a SuperPod storage partner. And again, today around the world, we have hundreds, several hundred DGX SuperPod systems installed, from 20 to over 2,000 DGX systems. One DGX is 8 GPUs. Today, for a state-of-the-art large language model like ChatGPT, well, Microsoft said 3 years ago, when there was GPT-2, I think, they said they were training it on 10,000 GPUs. They haven't updated that number, but I will tell you, I have many customers are wanting to build and building systems larger than 10,000 GPUs. And that storage requirement scales linearly every time we add 20 DGXs. The new DGX H100 SuperPod, the building block is 32 GPUs based on the radix of the switch. But you can start with 32 HGX systems or DGX systems and scale that linearly. And just like you don't want to cut up cables, you don't want to rebuild your file system, you don't want to change your file system architecture, you just want to keep on stacking up your file system, your server appliances. And so that's what we love about DDN. We haven't found a workload yet that we haven't been able to meet. And again, we've announced EOS, which will be our latest supercomputer. We have an early version of that on the top 500 system. I think only 128 nodes, 128 servers was number 14 on the top 500 list. Not particularly impressive, but only 128 servers. And so that system will grow at least 4 times in size and then up from there. Again, the power savings is, again, one of the key things for us. In our data centers, we're essentially out of power. We have to turn off older systems. If you're at our headquarters in California, in Silicon Valley, we're in Santa Clara County. That's the municipality we're in. There's some data center space in Santa Clara County. If you want data center power in Santa Clara County, get in line. Do you know when the next power is available from the power company? 2028. Now, obviously, people build data centers out of state and other places, but it's the same around the world, right? There isn't power in the city. There isn't power in the state. There isn't power in the country for new data centers. So we need to have a power-efficient solution, or we can't run our business. So again, very excited to continue having DDN as our partner with our H100 SuperPods. We have a lot of these go into enterprises that don't put them on the top 500. A lot of these are being bought at the nation level for national AI-based systems, and all of our largest systems to continue to go in, even when customers have a choice with DDN storage. It's a proven solution, proven ability to scale as we make the GPUs faster, as we make the network faster, as we make the software stack faster. Again, our current ML perf performance on our last generation is 2.5 times faster than when it first came out. The same chip, the system performance has gotten 2.5 times as fast. The storage requirement for the same systems have gone up 2.5%, or 2.5 times, 250%. So again, so important for that. So I know we've got a bunch of other great partners up to talk, so I'll take maybe one question.
Thanks, Mark.
If we have time. If not, I'll be in the back of the room afterwards.
Does anybody have a quick question for Mark? If not, we will move on. We do have plenty of others. Thank you, Mark. Really appreciate it. Thank you.